right, so we're going to continue looking at law of sines. Okay, we'll finish that up today. Just a reminder, first of all, what the law of sines is. Okay, if you don't remember, sine of alpha over A equals sine beta over B, which equals sine gamma over C. When you are using the law of sines, you never use all three parts at the same time. Okay, you either use the first two, the last two, or the first one and the last one. It just depends on what you're trying to solve for. Okay. When we use law of sines, first we have to know what kind of triangle we're working with, because there's two different laws. There's law of sines and there's law of cosines. For law of sines, there were three types of triangles that we could solve. And the way we described them was using three letters, A's and S's. Does anybody remember one of the types of problems that we can do with law of sines? Yeah?
SAS?
Um,
Or is it ASA?
We cannot do SAS with law of sines. We're going to talk more about that either today or tomorrow. ASA, yep, that's one of them. How about another one? Yep.
SSA.
SSA. Put that one there. And there is one more type we can do with law of sines. Yep. SAA or AAS. Yep, same thing. All right. So those are the three types you can solve with law of sines. When you create a table, the reason that these are all going to work with law of sines is because you are going to have a full row of information. Anytime you have a full row, when you make your table, that's law of sines. So there's two, and again, I don't know if we're going to get to these two today, but there are two under law of cosines. One of them we just said a minute ago, SAS. And does anyone know the last type? There's only one more way you can arrange those letters and have it be an actual solvable problem. Yep.
SSA.
Yep, all three sides. So the three on the left are law of sines, three on the right are law of cosines. Now, out of the three on the left, there's one case that we have to be careful with because multiple things can happen. Does anybody remember what case we have to check for 0, 1, or 2 solutions? Yep.
SSA.
Yeah, the SSA one. Okay. So that's the one that we've got to be careful when we're solving it because it could have 0, 1, or 2 solutions. First two types, angle, side angle, side angle, angle. You never have to worry about having a no solution or a 2 solution. Side, side, side. You also, no, side, side, side could have a no solution. All right, we'll talk about that later on. But it would never have 2. And side angle side, you never have to worry about no solution or 2. Right. So the 3 with the green dots next to them, never have to worry about anything tricky. Side, 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 not as bad as side, side angle, but you do have to check for no solution. Yes?
Wouldn't SSS be unsolvable if it was like a 30, 15, 5? Because then no two sides are greater than 30.
Right, yeah. If you don't have 2 sides adding up to be bigger than the third, that's a problem. Yep. All right, so let's take a look at the last case, side, side angle. And we've looked at the 1 solution. Today we're going to look at the 2 solution, the no solution. And then we'll review one of the, well, maybe we'll review both of these in terms of like a word problem. All right. So let's look at this one. Okay, we are going to make a diagram, but just looking at the table, can someone remind me how we would know that that is law of sines? Yeah.
There's 2 sides of one angle.
2 sides and 1 angle could be law of cosines, though. What is it about that? Yep.
Side angle.
Okay. Well, how does the table tell you that it's law of sines?
Because there's one full row, which
Yeah.
is A, and now alpha, and this is one extra value, which is B.
Yep, so we've got one full row, that's the key. Anytime you've got a full row, you're definitely going to use law of sines. And because we have one empty row, no way to find anything in it, we're forced to find something first. Okay, what is it that you have to try to find first here?
Beta.
Beta, yep. You can't do C or gamma because that row is completely empty. So we're going to forget about that last row for now. All right, so let's see if we can find beta. Remember, when you set up law of sines, it always starts out just like that. And can someone remind me, what could I put on the left? Sine of what over what? Yep, right?
Sine 35 over 6.
Yep, I usually put the known information on the left. You don't have to, you just need to put sine 35 over 6 somewhere. And what's going to go on the right if we're finding beta?
Sine beta over 8.
Sine beta over 8. Yep. And to get sine beta by itself, what are we going to do on each side? Yep.
Cross multiply.
Well, you could cross multiply, but that's actually going to give you an extra step. Because we want to get sine beta by itself. And if you cross multiply, you're going to be putting the 6 next to it. And we're going to have to get rid of the 6 after. Yep.
Multiply both sides by 8.
Yeah, I would just multiply both sides by 8 and save yourself a step. All right, so we've got 8 sine 35 over 6, which, because the 8 and the 6 are both even, you could reduce, but we're just going to type that in on the calculator, so I wouldn't bother reducing it. It's just a chance to make another mistake. Okay, so that's sine beta. What's my last step to get rid of sine and just have beta? Yeah.
Take the inverse sine of both sides.
Okay, perfect. We're going to take the inverse sine. Inverse sine and regular sine cancel out. Now, what's the domain of inverse sine? What's the largest number that you can take the inverse sine of? Yep.
1.
1. Okay, so if that number comes out bigger than 1 inside the argument, then we can't take the inverse sine of it. Right? And that would be an error. So we're gonna find out right now if this is a no solution when we type it in. So let's do inverse sine. 8 sine 35. Make sure you close your argument because you're done with the numerator. And then close your inverse trig function. Okay. So this number had to be less than 1 because I took the inverse sine of it and I got an answer. Okay. So 49.886 is definitely an answer for beta. Okay. All right, so let's put that down. Now, whenever we do inverse sine, we always have to check for a second answer. Okay. Does anybody remember the formula? And if you don't, this might help. Remember, you're looking for where sine is positive. The formula to find the other potential answer. Yep.
180 minus reference.
180 minus the reference angle. Yep. It wouldn't make sense to even be looking in these quadrants. How come? Yeah.
Sine isn't positive.
Right, sine isn't positive, and what's another reason that looking in these quadrants wouldn't make sense? Yeah.
In quadrant 3, it's 180 plus your reference angle, which is more than the amount of degrees in a triangle.
Yeah, all the angles in these quadrants are more than the amount you're allowed in a triangle. So you could never have an answer in 3 or 4. Right? All right, so let's take 180 minus the reference angle. And we're going to see what we get. We get 130.114. Now, before we write that down as a second answer, we have to check and see if it fits. What does this 130 have to fit with for it to work in the problem?
All right, with the 35.
It has to fit with the 35 because the 35 was given. Okay? Can you fit 130 and 35
Yes.
in the same triangle? Yeah, that's under 180. So what that means is now we have a second answer for beta. So what we're going to do is do a beta 1 and a beta 2. And what else does that mean? Yeah?
There's
I just have a question. How do you know, I don't know if you said this already, but how do you know if the second answer is possible? Like, simplified.
If it comes out, when you add it to the given, if it comes out less than 180. So 130.114 and 35, it only adds up to 130. What was the other answer? Was it 130? Yeah, 130 and 35 is 165. So it adds up less than 180. All right, so we're going to write that one down, 130.114. But what else does that mean? Yeah?
That also means that there could be multiple answers for gamma, I think.
Okay, anything else that it means too?
And C.
And C, yeah. It means we're going to have two answers for everything. Okay, so once you know you have a second answer, you have to find a second answer for everything that was not given. Whatever was given, don't worry about that. That's fine. All right. So now, if we want to kind of color code this, we have two different problems that we're doing, and we're using the same table. The A, the B, and the alpha are three pieces of information that are in both problems we're doing. So we'll call that one that one's in the purple problem. B1 is the purple problem, and so is gamma 1. Okay, those three angles are all in one problem we're doing. The other problem we're doing, I guess we'll call it the green problem. Okay. Alpha is in the green problem, beta 2, and gamma 2. Those are the three angles in the other problem. Right, and if you want to do the same thing with your sides, A is in the first problem, B is in the first problem, and C1 is the first problem. A is also in the second problem, so is B, and so is C2. So by color coding it, you can see the two different triangles we're solving and the three pieces of information that they share. All right. So now, what could I find next, now that I know beta 1 and beta 2? But Dex. What can we find next?
You can find like gamma 1.
Yep.
gamma 2,
And how would you find gamma 1?
using the Pythagorean theorem.
Well, what does gamma 1 represent in a triangle?
The hypotenuse.
No, gamma 1 is not the hypotenuse. Anyone else help him? What's gamma? What's gamma 1? Gamma 1 is an
Angle.
It's an
is
angle.
Cross groups.
Yeah.
Oh.
And what is the Pythagorean theorem used to find?
Yeah, the sides.
The sides.
So you're just gonna
Yeah.
subtract the alpha and beta 1 from 180.
Right.
Yeah.
And we don't have a right triangle here either. So we have to do alpha and beta 1 added together, subtract them from 180. So you can do them one at a time. You can do them all together. And if you get 95.114 for gamma 1, then you did it right. So that's gamma 1. And Nick, how would I get gamma 2?
You do the same thing with beta 2.
Yep. So add up beta 2 and alpha, that's 165.114. And that gives me 14.886. All right, so we've got all the angles now. And because I have gamma 1 and gamma 2, it gives me information in the last row, which means I can now figure out what? Yeah?
C.
Yeah, I can
1
find
and 2.
C1 and C2. let's set it up to do C1. Now, when you find C1, remember, if you want to think of it the way I color-coded it, C1 is part of the purple problem. So you need to use a purple row to solve for C1, a full row. There are 2 purple rows in that table, A alpha, B beta 1. Which row should we use to find C1? Starting with the full row. I know I need to use sine of 95.114 over C1. That I know. Yep, Matt? Yeah, I would use A and alpha because not only is it nice numbers, but it was given. So sine 35 over 6. And remember when you cross multiply, it's 6 sine 95.114, and then you divide by sine 35. Okay, so that is our answer for C1. So we've got 6 sine 95.114 divided by sine 35. That's 10.419. And now, when I find C2, there's only one number in this box that's going to change. What's the only thing in that box that's going to change when I do C2? Yep.
The 95.144.
Yeah, 95.114, that's going to change to 14.886. Okay. Just use the other angle. Because everything else stays the same, that's why I just hit second enter, and I can use pretty much the same calculation, just change that one number. Okay, so C2 is 2.687. And that's the law of sines problem, where it's side-side angle, and you got 2 solutions you have to find. Okay. That would count as 6 answers on the test, because there's a lot there. So that kind of problem would definitely be worth more than just a regular question. All right. Any questions on how we did that one? All right, and I told you I was going to draw this. I'm going to do that now. And I'm going to show you an example of, not necessarily to scale, but how you could get 2 solutions. So remember, this is side-side angle. What I'm going to do is I'm going to show you using that how you can draw another triangle that has 2 sides and an angle exactly the same, but the triangle looks different. Okay? Can't do this with any other case we've learned. This is the only one. All right, so first thing I'm going to do, go like that. I'm going to take the side in the upper left, and I'm going to make a copy of it. So far, does everybody agree that side and that side are identical? Okay. So now, as far as my sketch, I'm drawing something, and it does share a side. Okay. All right. Next thing I'm going to do is I'm going to copy that, and then I'm going to flip it, just like that. Now, by flipping it, is that side and that side still the same length?
Yeah.
Yeah. So now the picture that I'm drawing, it shares another side with the top one. And the only thing I can really do left is just connect the third side. Oops. Try again. Okay, so there's my third side. I'm going to group all that together. So where's the angle that they share? Well, if you move it up right there, they share that angle in the lower left. Okay, the angle in the lower left in the top picture and the bottom picture are identical. So those 2 are the same. So what I just did is I took 2 sides that were given and an angle that was given. I duplicated them to another picture, but it's not the same picture that I started with. Okay, this would be the second solution to the problem we just did, and the top one would be like the first solution. Okay. So for the given information, you don't have to worry about those three things having a second answer. It's just the third side that you don't know has two answers. That second angle you don't know has two answers. And the third angle you don't know has two answers. Right. That side-side angle with two solutions. Any question on that? All right, let's try this one. And let's see what happens here. Okay, so looking at that table, what does that table tell you?
Log signs.
Yeah, how come?
One full row.
One full row, yep. And because you have a row that's empty, and you have no way to find anything in that row, it tells you that it's the same case we did last time. It is side-side angle. All right, what do I have to find first?
Alpha.
Yep, I have to do alpha first. Again, if you have a row that is empty and you can't find anything in it, forget about that row. It's not going to help. Okay, so find alpha. Get your proportion ready to set up. And what's going to go on the left? Yeah, man.
Sine of 50 degrees over 1.
Yep, sine of 50 over 1. So dividing by 1, that doesn't even change anything. So that's going to be an easier fraction to work with. And what's going to go on the right? Right? Sine alpha over 2. So all I need to do is multiply both sides by 2. And I get 2 sine 50 equals sine alpha. And my last step to get alpha alone in that equation is, yep, I'll
Take the inverse sine.
perfect. Take the inverse sine. Okay, so remember, inverse and regular sine will cancel each other out. And now let's look at 2 sine 50. 2 sine 50 comes out to 1.53. So what does that mean is going to happen when I try to take the inverse sine of it?
You do it.
You can't do that. You can't take the inverse sine of 2 sine 50. Okay? So what do you think that means about alpha? Yep.
No answer.
Yeah, there is no solution for alpha. Now, normally at this step, we would take two angles, add them together, subtract from 180 to get the third angle. But we can't get the second angle. So what do you think that means about the third angle? Yeah? There's no solution for that.
And there's no solution for the side.
Right. And if you can't find the angle that's across from the side you don't know, then you can't find the side you don't know either. Okay. So a no solution problem is pretty quick. Right. But the way it works is either all three things that you are missing are either no solution, they're all two solution, or they're all one solution. Okay. So now I'm going to draw this one. And this one I'm going to draw perfectly to scale. What do you think is going to happen when I try to draw this? Yep.
It's missing the side of 2 angles. You would try to draw it.
Okay, so
It's not really a triangle at that point. It's just kind of like 2 lines and an angle. Because there's no third side, there's no other angles combined to make a triangle.
well, what's going to happen when I try to make it a triangle though? Because I can pick anything I want for the length of this side. I can make B as long or as short as I want. I can make this angle any size I want, and I can make this angle any size I want, because they weren't given. So I have some flexibility with how I draw that. I can't change what was given, but I can make what was not given anything I want to try to make a triangle. So any other thoughts what's going to happen?
there'll be infinite solutions.
Infinite solutions? Okay.
You interpreted it as that.
All right, so let's try to draw it and let's see what happens. So we need one side that's twice as long as the other. Okay, doesn't matter what units you use, you just need one side that's double the other. So let's draw it. So here's one side, and I need the other side twice as big. So easiest way to do that to scale is just put two copies together like that, and I'll group those. Okay, so now I have one side that's 1 unit long and another side that's 2 units long. The thing is, this one I group together, so I have the little green handle. This one I don't, so I can't turn it. But if I do group that with something, then it'll give me the little green handle. And now I can erase what I grouped it with. But now I can turn this any way I want. Okay. So, A is the side that is longer. Side A has to be at a certain angle. Okay, if it's going to make a 50-degree angle, I need to turn that so it's pointing roughly at 50 degrees. It's close enough. Okay, I cannot turn that anymore. Okay, if I change that, I'm going to be changing gamma, and I can't do that. Okay, so gamma has to be 50 degrees. Side C, we don't know. Side C is somewhere over there. Actually, wait, no, we were given side C, weren't we?
Yeah.
Yeah, side C is 1. So we can put side C somewhere over there, and we can turn it any way we want. Okay, so we can put it like that. Put it right there. Or if we want to rotate it, we can rotate it. I'll do that. That's fine. However you want to rotate that, okay, because there was no angle given for beta. So I can change that to be whatever I want. Now side B, I was not given that one. So side B can be as long or as short as you want to make it. What you can't do though with side B is rotate it. Because if you rotate it, you're going to be messing up that 50-degree angle in the lower left. Okay? So no matter how long or short you make side B, and no matter how you turn that side at the top, you just don't have the right information to connect these sides and make a triangle. It's impossible. The way you could make it work, well, if side C was allowed to be longer, that could make it work. Or if that angle in the lower left didn't have to be 50, but you could bring it up and make it like 30 or something like that. Right, so, or this side could also be shorter. If side A was a little bit shorter, then that might connect. Right, so there's lots of ways you can make it work, but the information they gave us, it will not work. Any question on why that was a no solution, or what happens when you try to sketch a no solution? And that is exactly 50. I used a protractor at one point that's in the program and drew that 50-degree angle. So that is 50. All right. So that's the no solution and the 2 solution. All right. So let's take a look at. Well, I'll let you pick. There's 2 problems. You want to do the one about the finding the height of the mountain, or the one where we're trying to find where the boat is in the ocean? Don't get so excited. I'm getting nervous up here.
The boat feels like Bermuda Triangle, something like that.
Okay, you want to do the boat one? All right. So we're going to try to find a boat. Okay, and basically what's happening here is there's a boat somewhere out in the ocean, and 2 Coast Guard stations can see, maybe they can see like a light on the boat. Okay, the boat doesn't have, their GPS isn't working, so they're not exactly sure where they are. It's cloudy, so they can't see any stars, and they're far enough away from land that they can't really see land. right? But they have a really bright light on their boat. Maybe they can blink it at the shoreline, and the Coast Guard can see like a dot blinking in the distance. All right. So each Coast Guard station is going to see where this like little pinpoint of light is coming from. Our 2 Coast Guard stations are going to be Zulu and X-ray. And the 2 Coast Guard stations are going to be 120 miles apart. Okay, that would be a distance that's known. You could just look that up on a map, like looking up the distance between 2 cities. So again, ship sends out the SOS. Again, maybe they're blinking their light, whatever they need to do. And they have a radio, so they can communicate with somebody hopefully seeing the light. And we're going to know the direction that each Coast Guard station can see the light in. Because if they're at their station, as long as they have a compass, they can just look where they see the light, look at their compass, and get the direction to that little light that's blinking in the distance. So to the first Coast Guard station, Zulu, they see the light blinking 40 degrees east of north. Okay, so what does that mean? Well, if here's your compass, 40 degrees to the east of north is like 40 degrees to the right. Oops. Kind of like this. This would be 40 degrees. 40 degrees to the east of north. You could also say 50 degrees and say it the other way. You could say 50 degrees north of east. So it makes a difference if you say east of north or north of east. That's 2 different direct ways to say the same thing. All right. So one Coast Guard station sees the boat 50 degrees east of north. The other station sees it 30 degrees west of north. So knowing that, what does that tell you right away? If one Coast Guard station sees the boat to their east and the other Coast Guard station sees it to their west, what does that mean about where the boat is?
In between them.
It's in between them. Right? Like for some of you, if some of you in the room said I'm to your left and others of you say I'm to your right, well then that means I'm between you. Right? If both Coast Guard stations were seeing the boat to their east or to their left or whatever, then that means the boat would not be between the 2 stations. That kind of helps us when we make a sketch. The boat is somewhere between the 2 stations out in the water. So the question is, how far apart, or how far is each station from the ship? Okay, so we got a lot of words to explain that problem. What would make this a little bit easier to kind of start to go through? Yeah?
Making a chart of A, alpha, B, beta, C, gamma.
Okay, so we can make a chart to organize everything. Yeah, we can do that. What else is going to help us? Yeah?
Stripping all the values from the thing, so 30 degrees west of north, 40 degrees east of north, 120 miles.
Okay, so we're going to use all those values, yep. And we could take all those values and,
I was gonna say make a diagram or something.
yeah, let's make a diagram with all those values. Okay? So when you're thinking diagram, we don't really want to think about triangles yet. We just want to think about objects we're putting in the picture. So what are some important objects in this problem?
Like their stations.
Okay, the 2 Coast Guard stations, yep. And generally, where would you find a Coast Guard station?
On the beach.
Yeah, somewhere right on the shore. So we'll draw in a line there. And this is going to represent land on this side, and then ocean on that side. All right, so we got 2 Coast Guard stations. Okay, so there's our wonderful Coast Guard stations. What else do we need in the diagram? Yep.
A ship.
Yeah, we need the boat, and we know that it's between the 2 out in the water. So let's just put a boat out there somewhere. There's our boat. And now we need to put in the directions and some numbers. What do we know? We need to kind of label which station is which. Which station is this one? The one on the left.
Zulu.
Zulu is to the west of X-ray. So let's put Zulu, X-ray, and they tell us how far to the west.
120 miles.
120 miles between the two. Okay. And now we have bearings to the boat relative to north. So what we need now is maybe like an imaginary line at each Coast Guard station that represents north. Close enough. That's north. That's north. Now, from each station, draw in a line that represents the direction that they see the boat in. Okay, so that first station sees the boat somewhere in that direction. And if that's the only station that could see the boat, they wouldn't be able to tell you how far away the boat is. They could say the direction the boat is, but they don't know if it's like 5 miles out, 6 miles, 10 miles. They can't get a gauge on that. But we have a second station that also sees the boat. And that's what those dotted lines represent. Okay. So it says the direction from Zulu is 40 degrees east of north. That means this is 40 degrees. That's the direction they see the boat in. And what's the direction from X-ray? Yep.
30 degrees west of north.
30 degrees west, or that's to the left of north. Okay, so we've got our diagram. We've labeled everything. Now at this point we need to figure out where the triangle is, and then we need to solve it. What are the 3 vertices of the triangle in this problem?
ASA.
In terms of the objects. Yeah.
The 2 stations in the middle.
Yeah, 2 stations in the boat. There's your triangle. So essentially what we're doing now is we are triangulating where an object is by observing it from 2 different points. That's what we're doing. So if we want to kind of abstract that triangle out so we don't have to look at as complicated of a diagram, we can put that there. That side's 120. What about that angle?
50.
That's 50, right? We need the one that's inside the triangle, not outside. 50. And the angle in the lower right?
60.
That's going to be a 60. And now to use the law of sines, you need a full row. That's not a full row. Okay, a full row means you know a side and you know what's across from it. Is there anything I could figure out there that would give me a full row?
You could add the 2 and then subtract them from 180.
Yeah, we can add these 2 angles up and subtract from 180. And how much would that be?
70.
70.
That's a nice one.
It's not that they asked for the 70, but you can't solve this problem without it. You need to know an angle and a side across from that. Now call your 2 sides whatever you want, A and B. And now it just boils down to solving for A and B. That's the distance from the boat to each Coast Guard station. All right, let's do A first. And then we'll do B. All right. What could I put on the left side of both of those proportions?
70 or sine 70 divided by 120.
Sine 70 over 120. Perfect. And the reason I can set both of them up at the same time is because A and B are not dependent on each other. I can find A without B and B without A. So I got the left side set up. What's going to go on the right side to find A? Yeah, Courtney?
50 over there.
Sine, can you say that again?
60,
60, yeah. And to find B? Yeah,
Sine 50 over B.
50 over B. Because once you get the diagram done, I think that's the hardest part. Just trying to lay everything out and understand where the triangle is. And then solving it, once you know the triangle, it's pretty straightforward. All right, so we've got sine 70. Actually, I'm going to do it this way. Let's do sine 60 times 120 divided by sine 70. Order of operations when when it's all multiplying and dividing, it doesn't matter, so it'll handle that fine.
I was gonna say sine 50 is for A, not B. On this, am I confusing them or no?
Sine 60 over A equals sine 70 over 1. So this is correct.
Okay.
Yeah. So then we got 120 sine 60 divided by sine 70. So that looks good to me. So side A is 110.59 miles. That's Zulu to the boat. Okay, and the other one they want is X-ray to the boat. That's side B. So we've got, let's do 120 sine 50 divided by sine 70. So that's 97.82. X-ray to boat. Did I say 97.82? And there you go. So now knowing the distance each Coast Guard station is to the boat, they can triangulate exactly where the boat is. So that's triangulating something when the object is between the 2 points. You can also triangulate something when the object is not between the 2 points. That was the one about the height of the mountain, which we didn't do. Yep.
Am I good to go?
Yeah, just so. Okay. With the height of the mountain problem, I'm not going to go through the whole thing. I just want to show you the triangle that ends up happening. You're trying to find the height of some object in the distance, whether it's a building or a mountain. It doesn't matter. And the object is in front of you the whole time. So what you can do is, instead of having two different people or two different Coast Guard stations, you make yourself the two different people. Right? You start here, and what you do is you measure an angle to the top of your object. And then, because your object isn't moving, this is a lot simpler than a boat, you go back a certain amount of distance. Maybe you measure back 1,000 feet, and then you measure the angle to the top of your object again. And what you just created is a triangle right there. You would know how far apart these 2 points are because you drove back 1,000 feet or however far back you did. It doesn't matter how far back you go. You just need to measure the same thing from two different points. Right? And you would know both of these angles. Well, actually, you would know angle 1 and you would know angle 2. Those are the angles that you measured to the top of your object. Right? So it's very similar to the Coast Guard problem, but the object you're measuring is in front of you the whole time. It's not between you. And then you have to go through and you have to, I think what you have to end up solving for first is this side right here. And once you know that information, then you have a right triangle right there. And then you can find the height of your right triangle. But you need a side first in the right triangle, and that's what the red triangle gives you. It will give you one of the sides. Okay. Any questions on that? Okay, every word comes a little bit different, so it just all boils down to making that diagram and then using law of sines to find a piece of information or pieces that you don't know. Okay. So I'll let you guys write that down. So on page 435, those are the law of sines problems. Keep in mind, you could have some with no solution. In fact, I know you do. And there might be some with 2 solutions. I think there's at least a couple that are no solution.
Yeah, I'll show you in some way.
4, 9, 11, 13, 14, 18, and 19. All right, so the last formula we're going to look at for solving triangles is law of cosines. We've already gone through what you can use law of sines for. Side angle, 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 side angle, side, side angle. Remember, side, side angle, that's the one we got to be a little bit careful with because you can end up with the no solution or 2 solution. So the other 2 types that we can solve, we already made a table for them earlier, is side angle side, which looks something like that, and side, side, side. So law of cosines allows us to solve these 2 types. Well, why not law of sines? Why do we even need law of cosines? Why don't we just try to keep using the same thing we've been using? Well, let's try and kind of see what happens here. Let's call this A, B, C, alpha, beta, and gamma. Try making a table for that top one. So A we know is 3, B we know is 12, C we don't know, alpha we don't know, and beta we don't know. But gamma we do, that's 100. So remember, when you use law of sines, you have to pick 2 rows. But when you pick the 2 rows, you can only be missing 1 piece of information. If I pick the top 2 rows to use, how many total pieces of information am I missing? 2. Not going to work. If I pick the bottom 2 rows, how many pieces of information am I missing? 2. And if I pick the top row and the bottom row, I'm missing 2. So no matter which combination of 2 rows you try to pick, you will always be missing 2 pieces of information. That's not going to work for law of sines. Okay. Any of the formulas we are using this week, you can only be missing 1 piece of information. Right? And the same thing would happen if you knew the side, and the side. You would have all 3 sides. You would not have a full row. So let me show you what the law of cosines is. Okay, you're not going to go through the proof of it. I'm going to ask you a few questions about it, but no proof. It's going to start out looking kind of like something I think you will recognize. What does that look like?
Pythagorean theorem.
Yeah, it looks kind of like, well, it is Pythagorean theorem, but we know Pythagorean theorem can only be used on can only be used on right triangles. And we're learning about non-right triangles. So what we need to do is adjust it. Okay, we're going to use the Pythagorean theorem, and we're going to put this adjustment on the end. We're going to subtract something, and by subtracting something, it allows you to kind of extend the Pythagorean theorem to any triangle. Okay? Makes the formula a little bit more complicated because there is something you got to put on the end of it, but it allows you to use it all of the time now. This is what you need to put on the end. It's not important what letters I'm using, it's more important the pattern of the letters. So let's kind of read through it and understand what the pattern is. Because this formula can start with a b squared, it can start with an a squared. If you want to use x, y, and z, it could start with an x, a y, or a z. There's all different ways you can write it. But as long as you get the pattern, you'll be fine. So it's one side squared equals the sum of the other two minus twice the other two, so it's twice the letters you used right before, times the cosine of the angle across from the letter you started with. So let's see if we can write the law of cosine starting with b squared. Okay. Anyone think they could tell me what would come next? Waylon?
C squared divided by b squared.
So we want to follow that same pattern. We're not necessarily rearranging this. We're just following the pattern of letters that we see. Yep.
B squared equals c squared plus a squared, or a squared equals c squared.
So b squared equals a squared plus c squared minus, and what would come right after the minus sign? Yep.
2ac
AC, so 2 times the letters we just used right before it,
cosine theta.
times the cosine of the angle across from the letter we started with. Yep. And what about the last way that we could write it? Yep.
B squared equals c squared minus 2ac cosine alpha.
Cosine alpha. Yep. And again, much more important to understand the pattern, because I'm going to give you eventually a word problem. It may not have labels in it, so you need to either put your own labels or just know the pattern. Okay? So that's the law of cosines. Now, I want to look at what would happen if that was a 90. Okay? You've never learned to use this formula on a right triangle, and there's a reason why. You've always used Pythagorean theorem.
If it was a 90, it would be 0.
What's the cosine of 90? Yep,
0.
0. Right? If you think of 90 on the unit circle, it has an x value of 0 when you write the coordinate. The cosine of 90 is 0. So if you fill in a 90 right there, you're going to get 0 for that part. What's 0 times 2 times a times b? Yep.
0.
0. And if you subtract 0 from something, you're not really subtracting anything. So when this angle is a 90, this entire part that we just put on the end disappears. And that's why you get just the Pythagorean theorem. Okay. When this angle is not a 90, which is what's going to happen this week, then this part will not be 0. And it's very important that we use it. So that's the 3 different ways we can write the law of cosines. So there's really 2 things that you can do with this law. You can either solve side angle side, or you can solve side side side. When you are solving side angle side, it's kind of a mixture of things. You do have to find one of the sides you don't know, but then you also have to find angles you don't know. You have to do both. With side, 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 you don't. Side, side, side is a little bit easier in the sense you're never finding a side. You're just finding an angle, and an angle. You're doing the same thing 3 times. Okay. So we're gonna start with a side angle side, because that combines both things that you'd have to do: finding a side and finding an angle. We got that written down. So let's try this. Okay. If you want, you can make a diagram. I'd say on a word problem, you definitely want a diagram. But you can tell without a diagram which law this is. which law is this one? Yep.
Side, angle, side.
And which law is that?
Oh, cosine.
Yes, this is law of cosines, okay? Because we do not have a full row. So law of sines is not going to work. If you're not sure and you can't tell, well, just draw it out then. So A, alpha, B, beta, and C, and gamma. Now, hopefully you can tell that it's side, angle, side. And that's law of cosines. Okay, when you have side, angle, side, you have to find the side you're missing first. What's the side that we're missing? Bella, what side are we missing?
C.
C. And to find C, you need to use the law of cosines that has C in it, but they all have C in it. So we got to make sure whichever version of the law of cosines we use, we are not missing more than one thing. So would I need to use version 1, 2, or 3?
1.
Yeah,
1.
right. I have to use 1 because I'm missing C. So you already have something you're missing in every formula. I also have to fill in an angle. There's only one angle that I know right now, gamma. So we have to use the top version of the formula. Okay, so C squared, A squared plus B squared, minus 2AB, cosine gamma. That's what we're going to fill into. All right, so start with C. Don't know. What's A squared?
16.
16, yep. And what's B squared? 49. Minus 2 times A times B. I usually do that as I write it down. Okay, 2 times A times B. What's 2 times A? Yep. 8. And then times 7? 56. Times cosine of, now you can fill in what they gave you, 42. Okay, I'd like to avoid any rounding until the very end. Is there anything else I can do on the right-hand side to simplify it without rounding? Yeah.
I would add a square root over the whole entire thing so that C doesn't have to, or C will be by itself.
Okay, so yeah, we can do the square root of something. And there's one thing there we can still combine
16 plus 49.
16 plus 49, which is
Let's see.
64.
65. Yep. And now we'll put that into the calculator. Remember, you can't do 65 minus 56. That's like having 65 minus 56 times something. You need to do the multiplication before the subtraction. And to do the multiplication, I'm going to have to round. Okay, so I would just, as far as doing it out, I would stop there with doing stuff by hand and get your calculator. All right, so we have square root of 65 minus 56 cosine 42. And that's 4.836. And that's C. And that's pretty much how it's going to go every time when you are finding a side. That's pretty much the steps. Now, let's label that side on here and see what we have now. When we started this problem, it was side, angle, side. That piece of information makes it more things now. What other kind of triangle is this besides side, angle, side? Yeah?
We can do side, side,
Okay, we could think of it as side-side angle. We have two sides and an angle that's not between them. We also have two sides and an angle that is between them. That was the original type. And one more. Yep.
Side, side, side.
Yeah, it's also side, side, side. If we think of it as these two types, those are both law of cosines. This type is law of sines. But what don't we like about side-side angle?
Two solutions.
Yeah, we could get into the two solution, no solution stuff. So we're going to avoid thinking about it as side-side angle, which means we are not going to use law of sines to finish this. Okay? We're going to stick with law of cosines. I'm not saying you can't. You can, but you have to be careful. Okay? So if we use law of cosines, it'll give us the answer as long as we do the math right. Don't ever have to worry about the two solution stuff. Because this kind of problem never has two solutions. Right? So let's finish it with law of cosines. It doesn't matter what angle you solve for. Once you know all your sides, you can find any angle you want. So let's do alpha. Okay, so to find alpha, how does the law of cosines start out? Yeah.
Can we do the same as the alpha just for the C?
Well, we can't use the same formula because that one doesn't have an alpha in it. That one has a gamma. So we've got to use a different version of the formula.
The A squared equals B squared plus C squared.
All right, let's start with that. A squared equals B squared plus C squared. So A squared equals B squared plus, and now I'm just going to take the last answer that I had and square it. So it's actually using more accuracy than 4.836. It's using the whole number that the calculator stored. So that's as accurate of an answer as I can get for squaring 4.836. 23.384. Okay, so we've got A squared, B squared, C squared. And what comes on the end? Minus 2BC. So 2 times B is 14, and I need 14 times C. So 14 times 4.836. I'm using a number I rounded. I mean, I don't really have much of a choice. So 3 decimal places, that's why we do that. 67.704. So now, this one, very different than the last one. The variable was pretty much by itself the whole time, except for the exponent of 2. This time, the variable has everything with it. So we need to combine like terms and get everything on the other side. Okay. Any like terms that I can combine first on the right side? Yeah.
49.
Yep, so we can combine the 49 and the 23, and we're going to get 72.384 minus 67.704 cosine alpha. Okay, 3 steps left to get alpha alone. What would be your next step? Yep.
Subtract the 72.384 from both sides.
Yep. Subtract the 72 from both sides. You cannot do 72 minus 67. Okay. Those aren't like terms. And if you get a negative at some point, that's perfectly fine. We're not worried about that. 16 minus 72.384. Minus 72.384. Okay, negative 56.384. Where I don't want a negative is the final answer. You can't have a negative angle or a negative side. But a negative in the middle of the problem, that's not an issue. Because what would we do for our second to last step? Yeah? Yep. Divide by negative 67.704. Negatives are gone. 67 is gone. And here, all I would do is cancel my negatives. I would not even do out 56 divided by 67. That's just going to be another rounding step you have to do. So just leave that. Okay, and my last step. So, James, what's my last step?
You do inverse cosine, what's that?
Good. We're going to do inverse cosine. And remember, when you are doing inverse cosine, you can only take the inverse cosine of a number if it's between negative 1 and 1. How do I know that that's between negative 1 and 1? Yeah?
Because the top is smaller than the bottom.
Yeah. First of all, it's a positive divided by a positive. So I know it's a positive number. And the bottom is bigger. So it's definitely less than 1. So if the top was ever bigger than the bottom at this step, you have a problem. That doesn't work. Okay, so inverse cosine of 56.384 divided by 67.704. It's 33.612. So I mean, on the test, if you had 33.613, 615, that's okay. If you had like 33.79 or something like that, that's a little too much rounding error. If we're going to 3 decimal places, then we shouldn't be that far off. And now the last, well, we already have 2 out of 3 angles, so just subtract them from 180. So minus 42. Minus 33.612. So that's 104.388. And that's pretty much it. That's the law of cosines. Okay. We didn't do side, 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 but there's nothing that happens in side, side, side that we didn't cover right here. With side, 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 you're just doing this 3 times, finding your angles. All right. So I think for homework tonight, we'll just focus on the law of sines. We're kind of halfway through. We'll do a little more with law of cosines tomorrow. And we'll start 8.3 tomorrow as well.
At the end of the last time, I mean, yeah, so what's the time?